Today we are going to start with exercise 1.1 question 3 part 1. As I have already made a video on question 1 and 2, so you can also check that out. So let's get started. Find the LCM and HCF of the following integers by applying the prime factorization method. So first one is already done for you, the prime factorization of 12. Now let's get started with 15. As also one more thing, that this is the first chapter, so it is very easy. As we will move on to the polynomials, coordinate geometry, so a little bit there will be increase in the level. So as you can see that trigonometry is way more trickier than this chapter 1, so it is very easy. So with practice and consistency you can really achieve and know how to solve problems in maths. So let's get started. Now it is divisible with 3, 5, then 5, then 1, then 21, then 3, then 7, then 7, then 1. Now the other number, that is second part, 17, 23 and 29. So let me also tell you, for LCM we are gonna take like 2 square, then we have 3, then 5, and then 7. And in HCF we have only 3 in common, so we will take 3. Now also if we will multiply this, then 2 2s are 4, 4 3s 12, 12 into 5 60, and 60 into 7 is 420. So LCM is 420, 60 into 7. Then second part, we it is not even necessary to do the prime factorization. You can do if you want to, but as you can see, these are just prime numbers and cannot be broken down further into their primes. So we will just write LCM and HCF. So LCM will be 17 into 23 into 29, and HCF is equal. So there's nothing in common, so you can just take like you are not even, it's not necessary to even write HCF because it's just like 0, so you no need. You should write the HCF when there's something in common, or else it's your choice. So let's get started with the calculation. 17 into 23, so 740, 21, 2 carry over, 3 1s are 3, 5. I'm doing this just in a very easier way, so you can understand and grasp the concept, and also you will have no problem in the calculation for 23 into 17, because these are numbers that we don't know the table of 23 into 7. So yes, now 7 3s are 21, then 3 1s are this, and then 7 2s are 14, then 1 carry over, 2, and then 3. So we are going to write 1, 9 and 3, so 391. Then 391 multiply by 29, it's going to be 9 1s are 9, 81, 9 18 27, 35, then 2 1s are 2, 18, 6 7, and then 9 3, 13, 11. So LCM is equals to 11339. This is the answer for second part. Let's move to third part. So for the 8 we have 2 4 2 2, and then again 2 1, and then for 9 we have 3 3 1. 25 you have this. Right now we will take the LCM. Before that we will write 8 9 and 25. So 8 is equals to 2 cube, 9 is equals to 3 square, 25 is equals to 5 square. Now we will write LCM is equals to greatest powers, it's like 3 square into 5 square. And again there's no need of writing HCF, because HCF, still I will write HCF will be just 1, and LCM for this will be, so we will expand this first and we will write it like this, 5 into 5. Now Now 2 2s are 4, 8, and then 72 into 10, that is just 720. Okay, so again, so this is 25, so here it will be 1800. So this is the answer, and we are done with this question. So let's move to question 4. So our question is, given that HCF is equals to 306 and 657. So for this number it is 9, then find LCM. So there's a relationship or formula that I've already told you in my previous video, that is LCM into HCF is equals to A into B, or also you can write it as product of numbers product of numbers. So we can write that 306 into 657 is equals to HCF and then LCM. So now this side 9 is in multiplication, so here it will be in division. So we will write it as LCM is equals to 306 into 657 upon 9. So this will be 34. So we will write it as 34 multiplied by 657. That will be 22338. Answer. So this was question 4. Now let's get started with question 5. So our next question is, check whether 6n can end with the digit 0 for any natural number n. So it is very simple that if it will end with 0, then it is divisible by 2 and 5. It will be a factor of 2 and 5 both. So let me tell you how we do this. It is also given in NCERT book how to solve this in example 1. So this is example 1. As you can see, consider the 4n where n is a natural number. Check whether there is any value for 4n ends with the digit 0. So if the number 4n for any n were to end with the digit 0, so what will happen, that it would be divisible by 5, correct? That is, the prime factorization of 4n would contain the prime 5. So it is also written in a very easy language. Like then other examples, you can find it is written in so much easier language, so you can understand it so articulately. So yes, this is not possible because 4n is equals to 2 square n. So the only prime in the factorization of 4n is 2. So the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other prime in the factorization of 4n. So there is no natural number n for which 4n ends with the digit 0. So let's get started. We can also write like here, n is a natural number and let 6n end in 0. So 6n is equals to 2 into 3, right? If we will do the prime factorization of 6, we will get 2 into 3 into its prime number. So this will be the prime factorization of 6n. So we will write that is prime factorization there is no factor 5. So as you can see, there is no factor 5. It is not ending with 0. So we can write that we can write the line of the book, that is, we can just write exact this line. So the uniqueness of the fundamental theorem of arithmetic guarantees that there are no other prime in the factorization of 4n, 6n. So there's no natural number n for which 6n ends with a digit 0. It's just the same. You just need to learn and practice the process, and it is very easy. So here we are done with 5th question. Now let's move to 6th. So we have explained why 7 into 11 plus 13 and 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite number. So for this, it is very easy. We will just write that 13 we will take 13 in common because 13 is coming 2 times. So we can take this as common and then we can write it as 7 into 11. And instead of 13, as we have already taken it as common, we can write it as 1. Then we can 77 and 8. So this will be 78 multiplied by 13. So that is 13 into 78. 13 into 78 cannot be a prime number. Like, it is not a prime number because it has a factor 13. अगर 13 कॉमन में है तो 13 into 78 एक प्राइम नंबर नहीं हो सकता because it has a factor 13. Exactly. So you can write that, right? Now, so here we can see that 7 into 6 into 5 into, so 5 is common. 5 is common. It is just the same as this one. So here we took 13 as common, and 13 was the factor of 13 into 78. So this was not a prime number. Same with this. 5 is the factor with this in multiplication. So this is not a prime number. We can write it as it has a factor 5, or we can just say therefore it has a factor 5, which is not a prime number, so it is a composite number. So now let's move to the next question. So as we can see, this question is lengthy, but the answer is not lengthy. It's very easy. So there is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? This is very easy, as I have already said. So first we will write time taken by Sonia is equals to 18 minutes. Same with this, Ravi is equals to 12 minutes. So now we will take the LCM because it will tell the exact number of minutes after which they meet at the starting point. So we will not take the HCF and YLCM because this is the lowest common multiple. So when we will take the lowest common multiple, it will show you the correct answer because we are talking about at what time they will meet again at the same point. So for question like this, we take LCM. As we will further do more questions, you will understand the concept. That is really easily done. So yes, we will start with question 7. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Suppose they both start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? So for this we will take the LCM because when in the question it is asked at what time they will meet in the same point. So it will be the minimum time that is required for them to meet at the same point. So we will take LCM because in most of the question when minimum or smallest is there, we used to usually take out the LCM. So let's get started. Time taken by Sonia is equals to 18 minutes. Time taken by Ravi is equals to 12 minutes. Now the LCM of 18, 2, 9, 3, 3, 1. Then 12, 2, 6, 2, 1. So 18 is 2 into 3 square. 12 is equals to 2 square into 3. So LCM is equals to greatest power. So we will take 2 square into 3 square. 2 square into 3 square is equals to 4 into 9. So 4 into 9, 36 minutes is the answer. So we are done with the exercise 1.1. See you guys in next week.